Hello. We are going to start a new topic or new subject, we can say, that is networking. Okay? Now, the first question arrives is what is networking? What is computer networking? Okay? Basically, networking is a collection of multiple computers or devices connected to each other, which allow the sharing of resources and information. Okay? The subject we will be studying about different types of networks, how devices are connected, how things works. Okay, let us discuss and move further. Okay. Now the first topic which we are going to study under the networking is network topology. Okay. What is network topology? Network topology just explain or tells us about how the computers or systems are connected with each other. Okay. Let us see different types of topologies. Okay, here it is a star topology. You can see how the computers are connected with each other. There is a centralized system from which all other computers are connected. Okay, here, this is a ring topology. Okay, all the computers are connected in a ring way. Okay, it is bus network topology. Okay, you can see how the all the systems are connected using a center wire. Okay, it is called mesh topology. In this topology, you can see all the computers are connected with all another computers. Okay, this is mesh topology. It is a tree topology. It's nothing other. It's just a combination of a star and bus topology. Okay, you can see we will be knowing about different types of network. Okay, first network is PAN, that is personal area network. Okay, basically we can say that it is work for a person or here it is the range given range limit is up to 10 meters. Okay, it is created for personal use. Okay, the next is local area network. It is used in offices, schools, or small organizations. Okay, the next is house area network. Okay, it is used for how many devices like personal computers, phones, printers, etc. Okay, next is campus area network. Okay, it is distributed in an organization or the campus. Okay, now the next is metropolitan area network. It is spread over a city. That's it. Next is world wide area network. It covers all. It is it covers a wide geographical location. Okay, even countries. Okay. The next is global area network, which covers entire global area. That is entire globe. Okay. Now here we will be knowing about bandwidth, latency, and throughputs. Okay, bandwidth. This is a capacity of a network in see the maximum data transfer capacity of a network. Okay, where the latency measures the time delay. Okay, we can say the time taken by the data from to reach from source to destination. That can be latency or that can be a time delay. Okay. Now, next is throughput, which is see bandwidth is the maximum data transfer capacity of a network, but we know that it is not practically it is practically quite difficult to get data or network exactly the same as the bandwidth. So the throughput defines the actual data which are being flowed, which are we are getting. Okay. Now we are going to know about half duplex and full duplex. Okay. In half duplex, we cannot transmit and receive at the same time. For example, walkie-talkie. You must have seen walkie-talkie. In that we can whether we can transfer or transmit or we can receive. We cannot transmit or receive both at the same time. Where the full duplex is, we can in full duplex we can transmit and receive in the same time. Okay, like we talk in our phone calls. Okay, it is full duplex. Okay, let's know about VPN. Okay, virtual private network. VPN provides secured tunnel between the different networks. Okay, using VPN, a client can connect to the organization networks remotely. Okay, there are many advantages of VPN. You can see here. Okay, it is mostly used for secure data transfer or secure transaction. Okay, network infrastructure contains three categories of hardware components. Okay, end devices, intermediate devices, network devices. Okay, end devices form the interface between users and the communication network. Okay, for example, you can see here computers, printers, telephones, etc. etc. Mobile phone, tablet, वगैरह. Network devices are the devices that connect and manage the flow of data among different devices. Okay, we will be studying about devices in details further. Okay, now coming to an important slide, that is protocols. Protocols in networks. Okay, what is protocol? Protocol is a set of rules and conventions that govern how data is transmitted and received between devices. Okay, there are the few protocols available in the networking. Okay, first one is TCP, that is Transmission Control Protocol. Okay, this protocol it ensures that data packets are delivered without errors in the correct sequence. Okay, here another protocol is UDP. Okay, it is quite faster than TCP, but they may cause errors and incorrect sequence too sometimes under this protocol network. Okay, it is commonly used for video conferencing. Okay, the other protocol is Internet Protocol. Okay, this protocol provides the addressing and routing functions necessary for data to transmit it from a source to a destination across internet networks. Okay, another protocol is HTTP. Okay, it is called the foundation of data communication in the World Wide Web. Okay, here the another is HTTPS, that is Secure Hypertext Transfer Protocol, which is now nothing other. It is just the extended version of HTTP. Okay, it just add an extra layer of security. It is more. It is considered secure. Okay. Another protocol is File Transfer Protocol. Okay, this protocol is used for transferring files between a client and a server. Okay. Another protocol is SMTP, that is Simple Mail Transfer Protocol. This protocol is used while sending mail. Okay, it binds how email clients communicate with email servers to send outgoing messages. Okay, another protocol is POP3, that is Post Office Protocol version 3. Okay, this protocol is used for retrieving mails. Okay, it allows users to download their mails to their local computer for offline access. Okay, next topic is OSI model. Okay, what is OSI model? It is a seven-layer architecture used to transmit data from one system to another. Okay, it is the diagram of OSI model. Here you can see the 7 layers. Okay, so the first layer is physical layer, and then data link layer, and then network layer, transport layer, system layer, representation layer, and application layer. We will be seeing it one by one. Okay, in this diagram you can see that from client side the information passed through application, then presentation, then session, then transport, then network, then data link layer, and then physical layer. Where in server side the series get reversed. Okay, Now let's know about it one by one. First one is physical layer. Okay, the main function of physical layer is to transmit raw data over a physical medium. Okay, it establishes physical connections. Okay, the devices which are used in this layer is hub and repeater. Now let's discuss about the devices too. Okay, what is hub? Okay, what is hub? Okay, the main function of hub is that it connects multiple devices uh, uh, into one network. Okay, it provide data to all the connected devices. Okay, the second device is repeater. Okay, it repeats the signal, or you can see that it amplifies the signal. Okay, amplification means, what is amplification? Amplification, mm, we convert weak signal into a strong signal by amplifying it. Okay, so that it can travel, can long range. Okay. Now the second layer is data link layer. Okay, the main function of this layer put data into frames. Okay, or data packet into frames. Also, it detects and corrects error that may occur in a physical layer. Okay, the devices used in it is switch and bridge. Okay, switch is a device where if any data get corrupted, it deletes or it removes that data. Okay, or data packets. The third layer is network layer. Okay, the function of network layer is to route data packets from the source to the destination across multiple network. Okay, or multiple network nodes. Okay, the devices used in it is router. Okay, there are three switches. Okay, what is router? Router routes the data packet based on the IP addresses. Okay, fourth one is transport layer. Okay, the function that it ensures the reliable data transfer between devices. Okay, it ensures the end-to-end data delivery to, it manages error detection and correction. Okay, the devices used in this layer is firewall. Okay, and load balancer. Okay, gateways. It manages um, connection between application devices. Okay, layer. It translates, compress, and encrypt data for transmission. Okay, now the last layer is application layer. Okay, provides network services directly to the end users. Okay, and interact with software applications. Okay, the protocols which that used, as we have discussed earlier, that is HTTP, FTP, DNS, and many more things. Okay, here's some summary of all the layers. Okay, of OSI model. Okay, there is one more model developed by the Defense Department of US. Okay, in 1860s around. Okay, it is a compact version of the FOSI model where only four layers are there. Okay, you can see here the application, presentation, and session layer are considered an application layer, and data link and physical layer are considered network interface layer. Okay, this is a basic client server architecture. Okay, where our devices or client request for data and server response to the client. Okay, it is a P2P architecture, that is peer-to-peer architecture. In this network or architecture, mm, each setup or each system or nodes acts as a client and a server. Okay, they are just connected to each other. Okay, without any centralized server. Okay, it is a peer-to-peer application. Okay, in this model, every client is a server and every server is a client. Chatting apps are can be example of it. Okay, you can see what is MAC address and IP address. Okay, both are used for uniquely define a device on the internet. Okay, the main difference between MAC and IP address is that MAC address is used to ensure the physical address of a computer. Okay, it uniquely identifies the devices on a network. Okay, while IP addresses are used to uniquely identify the connection of a network with that device taking part in a network. Where IP addresses identifies the devices. Okay, where the MAC addresses identify the connection of the network. Okay, IP addresses are categorized in two ways. Okay, like for functionality, the IP addresses are divided into two ways. Two. Okay, first is public IP addresses. Okay, public IP addresses are global, unique, and routable on the internet. Okay, that is, it is unique and can be found on the internet. Okay, it is provided by our ISP, that is Internet Service Provider. Okay, for communicating a device or which is present in another network. Okay, where the next one is private IP addresses. Okay, it is used within a private network such as home or business network. Okay, it is not globally unique and can't be routed or found. Okay, by its version, IP addresses are classified in two categories or two types. Okay, one is IPv4 and another one is IPv6. Okay, IPv4, that is Internet Protocol version 4. It is older and more widely used version. Okay, IPv4 is are based on 32-bit numerical address. Okay, that is, it can support approximately up to 4.3 billion unique addresses. Okay, where in where I can IPv6, which is a newer version of the Internet Protocol. Okay, it is based on 128-bit numeric addresses. Okay, modem is a device that connects our local network to the internet. Okay, it modulates our signal, or it modulates or demodulates our signal. Okay, coming from the internet.